Hello, my name is Siddhant Singh.
And my name is Dhruv Palmeru, and today we'll be talking about the selection sorter. Two similar algorithms to the selection sort are the bubble sort and insertion sort. The bubble sort works by swapping the two adjacent numbers if the adjacent number is smaller than the current indice, and therefore placing the larger number at the next indice. The insertion sort works by taking the number in the unsorted portion of the list and then selecting which index it should be placed in the sorted portion of the list.
So what we're going to do is we're going to swap 2 with the first number in the unsorted array. So we'll swap 2 with 7. Okay, and now we're going to sort again, this time without 2. Just we're going to sort here because this is our unsorted portion. 2 is already sorted, so let's do it again. So 7 is our lowest number. Is 7 less than 29? Yes. Is 7 less than 19? Yes. Is 7 less than 15? Yes. Is 7 less than 33? Yes. Is 7 less than 11? Yes. So we'll swap 7 with the first number in the unsorted portion, which will be 7. So 7 will just swap with itself, same here. Next we'll look again. Now this is our sorted portion, 2 and 7. So now we're going to look at our unsorted portion again. So let's see, is 29? 29 is our lowest number. Is 19 less than 29? Yes. So that's our new lowest number. Is 15 less than 19? Yes. So 15 is our lowest number. Is 15 less than 33? Yes. So no. 15 continues to be our lowest number, but is 15 less than 11? No. 11 is less than 15. So now 11 is our new lowest number. So we'll swap it with the first number in the unsorted portion. And now we'll continue again. So 19 is 19 less than 15. No. 15 is our lowest number. Is 15 less than 33? Yes. But is 15 less than 29? Yes. So 15 is our lowest number. We'll swap it with the first number in the unsorted portion, like so. And we'll repeat the process this time with these three numbers are unsorted portion. So it's 19 less than 33. Yes. Is 19 less than 29? Yes. So we'll swap 19 with itself. 19 stays where it is. Then here is 33 less than 29? No. So we'll swap it.
So as my friend Siddhant just showed you, the selection sort works by taking the smallest number in the unsorted portion and placing it at the end of the sorted portion. The best case scenario for the selection sort is when all the numbers are in order, and this is because it has to make n number of comparisons but 0 swaps, and therefore the time complexity for the best case scenario is n. The average case scenario is when the numbers are put randomly in order and the number of comparisons being made is n squared over 2, while the number of swaps being made is n, and therefore the time complexity here would be n squared. And now finally the worst case scenario for selection sort is when all the numbers are placed in reverse order, and here it's the worst case scenario because the number of comparisons that are being made is n times n minus 1 over 2, and the number of swaps being made is n, and therefore the time complexity here is also n squared. However, this is the worst case scenario because it has to swap each number after the original number, and the whole list is unsorted at the beginning, while in the average case there are some sorted numbers already, and it can skip over some numbers that it knows are bigger than the smallest number. The space complexity for the selection sort is 1 because it never has to create a separate array like merge sort to store any of the numbers, and it only has temporary variables like the minimum value and also the numbers it has to swap.